Kavitha is a, let me just pull up your bio, Kavitha, because I want to do you justice. There's quite a lot to introduce here. You are a design entrepreneur specialized in the field of computational design, 3D modeling, and advanced manufacturing. You've got 12 years experience in designing and product development and 8 years in the field of 3D printing. And Kavitha is driven to empower the use of technology in creative industries. Kavitha loves to explore the intersection of design, technology, and manufacturing, creating an innovative cross-disciplinary platform that embraces values of digital insertion and diversity. Kavitha is a computational designer, design development professional with certification in, just wait for this, Rhino 3D, Grasshopper modeling software, and a Masters of Architecture focused in advanced architectural design and this is from a German university. My pronunciation, I'm sure, will be terrible, despite the fact I've been trying to teach myself German. Staatliche Hochschule für Bildende Dendit. I'm going to give up. I'm sorry, Kavitha. Kavitha, you are an ambassador for women in 3D printing in the APAC region. So thank you very much for doing that. It's a pleasure to introduce you. And please feel free to share your screen with us.
Sure. Hi.
I'm sure your German's much better than mine, Kavitha.
Not as good. I guess it's one of the most difficult languages for me. Yeah.
And Kavitha is the founder and creative head of Into Design. So yeah, your screen looks is great. It's a PDF, I assume.
Yes.
Yeah.
Let me just make it full.
Yeah, that looks fantastic. Well done.
Perfect.
Okay, take it away. Thank you.
Okay. So thank you, Alex, for the introduction. So I'll be sharing a little bit on my journey on how, from being an architect, I've moved into industrial design. And the main part of what I wanted to really talk about today is how you can, how design gets impacted or influenced, or, more ways to handle design while you 3D print. Right. So I'm giving most of my research that I've done over the last few years, and probably a little bit more in the coming years as well. And to start with, you've given an introduction. I would like to, kind of go in a timeline format just to kind of tell how I kind of embrace this technology through over years. So basically, I am an architect with a master's degree, but slowly over time with 3D printing as a specialization, I have kind of grown in more in the industrial design sector. And with the master's degree program, what I actually kind of started working with was more into understanding how you work with digital in terms of 3D modeling, that is translating your idea into a developable 3D model, which can be manufacturable as well. So this was sometime back in 2012, and then slowly I moved into 3D printing has always been there. Like I think the first time I saw a 3D printer in the size of a big room, it's a simple FDM, but a really huge one back in 2012, which was in Germany. So slowly I was starting to work quite a bit on how do you develop for 3D printing and so on. So a lot of passion comes in for me when it particularly do design for 3D printing. So I wanted to slowly become a specialist in this kind of modeling. So I got myself, since I have a design background, I don't have much of a technological expertise. So in order to kind of bridge that, I did a certification on on 3D printing, and slowly kind of learned Python. So I can code my own complex geometries. And right now what we have been doing in my company is almost 5 years old, where we do quite a bit of design consultancy, and not just design, but we also do design development. Like let's say someone comes with an idea but has no clue on how to make it into a additive manufacturable model. Right, so we try and make an efficient and optimize their design solution to be manufactured in a very optimized manner as well. So that is part of what we do with the manufacturing consultancy as well. Yeah, prototyping, it happens on an everyday basis. And one thing that I love to do is kind of share my share my knowledge along with the other design teams as well. So this is in a nutshell what we do, and I've been working with quite a bit of industries, automobile, jewelry, robotics, architecture, and product industry. Today, I think this is going to be not more about what projects I've done, but how we've done, what are the tips and tricks on handling the design process. So to me, I believe that digital technologies are no longer tools for making, but they're primary tools for thinking. And there's this famous thing that most people have a myth on, that if you learn quite a bit of digital technologies, your computer becomes your master, right? That's not true. If you know how to use the right digital tools, your mind is always the master, right? So that is something that I really rely on. And in today's presentation, I'm going to be talking on three basic things and probably highlight design and optimization. So what I mean by design is the process of ideating and then developing a 3D model. And once that is done, how do you optimize it? How do you make it efficient for manufacturing? There are two things. You will have to satisfy the clients. You'll have to satisfy the user group. So we'll be talking a little bit more on those lines. And after optimization, how do you do prototyping and testing? What are the patterns of how you can get the user group for testing? We'll be talking about that. And finally, the manufacturing process. So 3D printing has revolutionized the way we think. Previously, you always think, okay, if I would love to design this form, but then is it manufacturable? That is always the question for any designer, right? Probably 15 years down the lane, you would think of a really simple structure, which doesn't have much patterns on top of it, right? Not much complexity. So you would go with a very simple ring format. And then now with 3D printing, your design ideologies, you can start thinking out of the box, go for complex forms, right? So that is one way 3D printing has, kind of revolutionized the thought process. And the other one is, how do you ideate it, right? Initially, yeah, you can sketch. If you're very good at sketching, cool. You can, kind of make people understand how it can be done. But with 3D printing, you can do a quick prototype. I'm not talking about an end user prototype or a prototype that comes much after. I'm talking about in a very early stage, you trying to understand how the model, the touch and feel of it, right? Sometimes even the texture of it can be 3D printed. So redefining the aesthetics in an early stage is a very, very important factor. So that is another one. Another one is, testing out different materials. How will it be if it is transparent, and how will it be when it's opaque? So that's another possibility of your ideation process. Right? And then the production, right? Production happens from a small part, from looking at a furniture as your, or this is a, I think most of you would have seen this. This is a habitat that they're trying to 3D print in Mars. So this is the kind of production variation that we are looking at right now in the whole world. So the way you kind of think about it, like look at this. This is a habitat, the shape of a habitat, right? Initially, it's all those tipped roofs that you kind of think, if it's Earth, you think of it like this. But if it's Mars, you're thinking in a very different form evolution, right? So this is the whole idea about why I really wanted to kind of stress upon how important it is to understand design, and how it is important to understand the end manufacturing, so you can do justice to both. Now, looking at the process of it, I'm just going to briefly elaborate certain things that I wanted to share today. So everything starts with everything starts with the research and the preliminary data collection. Now, understanding the client's brief becomes the most important, the starting point, right? And then once you're done that, how do you collect all the data? And particularly, these are data collection that is a very intensive study on the design of the product. Now, how do you do that data collection is you initially meet the user group. So generally what happens is when a designer starts developing a product, once it's ready, probably in the testing time is when most people, kind of show it to the user group. But instead of doing that, what if you try to meet the user group in a very, very preliminary stage, probably in the ideation stage or while you collect data? So that kind of helps you to understand, determine the problems, the influencing factors, and what are the success factors. So, you kind of set certain parameters, certain rules, and then determine what the design problem is. Now, once that is done, how do you find what is the most optimized methods and tools to develop the product? And simultaneously how iteration works and how you can test the product. But in the whole set, there is one thing that most of us also look at the end, which I really want to point out to, kind of add it in the front part. What kind of manufacturing technology are we going to follow for this particular product? What form, what geometry makes it more efficient to be printed? So that again comes into a very primary study module, which is your research and data collection. So that is identifying and understanding the related manufacturing feasibility. So you produce a very holistic form. So design is never a linear process. It's a non-linear process. You can jump from here. You've done the prototyping. You don't like it. You can always go back and understand what the user problem is. So that's the kind of process I kind of embrace while I'm doing my projects as well. So apart from it, coming to the next stage, that is, when you have the design problem set, when you have the set of parameters that you want to work with. For me personally, though I'm more into digital working, my initial idea is always in terms of a pen and a pencil, because I feel that that's the quickest possible way for an output from your brain to come out as well. So once that is done, I also try and embrace a particular design strategy called the user-centric design, because most of the products that are there is either a single user group. I design quite a bit of terrain interiors where multiple stakeholders come in, and the kind of the touch, how do they touch, how do the anthropometrics work, how do the ergonomics work. So there are quite a bit of factors that comes in there. So user participation, understanding the user experience, all those are very, very important. And simultaneously the technology, what kind of technology you're going to use in terms of manufacturing, what kind of digital tools are you going to use in terms of to aid manufacturing process, and so on. And then comes the business goals. Definitely, if you want to satisfy your client, and you'll need to kind of find the strategic fit. So this is, this can be a whole huge topic, but in a way, this is something that I cannot skip, which is user-centric design. And coming to the ideation phase, I just wanted to add a little bit of tips on what would you need to follow while you're doing 3D printing. Now, the first very important thing is the material that you start using. You can, if you're trying to use wood, what is the limitation of wood? How can 3D print? Does it print via powder, or are you using wood and a little bit of joinery together? Right? Maybe a plastic joinery which is embraced into wood, or a steel joinery that is embraced into wood. So, those kind of, you can always think of, mixing up materials along with 3D printing, get some natural feel into it, and, kind of innovate on the joinery part. So this is something that you need to understand first. And then multiple parts assembly can be reduced. So there is, though the first point talks a little bit about heterogeneous, if you want a particular part, like let's say a mouse is a two-piece part, right? Now, what if you have other things, like you want to make a mouse that is a single piece, right? Or single piece. So you have to design it in a very monolithic kind of approach. So those can be reduced here. And freedom in manufacturing process. Now, that's one major thing. Making a design that's not multiple parts, but the freedom, the manufacturing process can go as complex as possible. A simple form can be done via injection molding, but a complex form can be done via 3D printing without any time or without any additional cost. So right now, if you're a designer, you can think out of the box, because you do have solutions to be manufactured, right? So again, important thing is, while in your ideation process, create quick prototypes, which will help you humongously while you're doing a design making decision. Like let's say you're a person who have 5 options, you find it very difficult to take a call. Just print all 5, touch and feel it, because the minute you see it in a scaled scale model, you'll understand the kind of anthropometrics that revolves around it as well. And finally, once you've tested these prototypes, test it with the client group or the user group. So this, this we've done with quite a bit of clients. You can use virtual reality to sense it. You can use Sketch to sense it. But the best, the best conveyance in terms of the idea has always happened through 3D printed prototypes, because certain times what we also do is try and get the texture out, so they can touch, they can feel the excitement that they get, which is tangible, is much higher. So participatory design is something that you can incorporate while you're doing 3D printing for designing as well. So yeah, definitely go crazy with the forms, think out of the box, be innovative, because this is the right time, because with 3D printing, anything is possible. Now, coming to the next part, I would say there is, I mean, if you want to live, you need food, right? Very similarly, if you want to 3D print, you need a 3D model, a good 3D model. Now, this is what I kind of specialize with. If you have an idea, if you have a 3D printer, one thing that bridges these two are definitely the 3D model, right? A very key to any efficient 3D printing is always the modeling part. And I've personally seen quite a bit of people struggling to develop their idea into a 3D printable format. So my research kind of goes into these lines. Today, I'll be, kind of sharing a little bit on an introduction level, probably for the next year, a little bit more complex form solutions I'll also try and give you guys. So this is the general process for those of you who are a little new. Now, you have an idea, you develop the idea via there are quite a bit of modeling softwares. There's Autodesk Fusion, there's Rhino, there's CATIA, there's AutoCAD, right? So there are quite a bit of things with which you can generate a 3D model. The thing is, try and master in one. And if you can do, from simple to complex forms, over time, if you use one particular software, you'll be able to kind of, get advanced into it. And once this is done, you turn it into an STL file. And once the model is super ready, there are quite a few, again, I'll be sharing a few tips and tricks on how to prepare a 3D model for printing, right? You slowly move to the slicer software that turns it into a G code and then ultimately prints. It's a very, very simple, system or a translation of an idea to a product. And that's, again, the whole satisfaction for me and the passion for me is that, you have an idea quickly in an hour or two, develop the idea and create an end user part. All right, so that's one more thing. I extensively use Rhino. Probably the only software that I use is Rhino 3D. And I'm also a trainer, an authorized trainer for this particular software. And Grasshopper is another coding language that I use for generating designs and the iterations of the design. It's a very simple software tool, though this is the power of my, the entire work that I do. So I just wanted to give a little bit of an introduction. This is a NURBS-based software, which will allow you to do any organic freeform surface or solid because of their flexibility and accuracy. And NURB models can also be used. The whole idea of Rhino is also that it is a very good product to use for manufacturing because you have the natural lines, the natural curvature, surface curvature are very, very good, and you don't have much meshing that happens on the surface. So it is a very, very good thing for manufacturing as well. We call it as a file to factory system. So basically this is a one-stop solution that I use, kind of get the idea, develop the idea, prepare the file for 3D printing and convert it into an STL. So the entire process, what I showed you before, all happens in one shot, right? And then I prepare the G code file. So on these lines in this particular software, there are quite a bit of, so I'm just showing you the first very important 4 things because we don't have a lot of time. But if anybody has any doubts on, how do you convert your idea or how do you do 3D modeling, I'm always open to connect. So the very, very first thing, again, coming to tips and tricks and, how do you handle 3D models? The first important thing is to work on a scale. Right? Because working on the right scale and the precision is the key to modeling. And the second one is working with functional prototypes. This is something that I've seen as the most common error in most of the companies or most of an individual case as well. Particularly when you're kind of working on functional prototypes that needs to fit in and fit out, you'll notice that the minute you print, it kind of doesn't fit in. That is because of the tolerances, right? If your printer you need to always give more tolerance than the printers. Like if let's say your printer is 0.01, you need to add 0.001 tolerance in the 3D modeling file. This is definitely something that not many people know about. Another is there's a really good command in Rhino that we use, which is for checking for bad objects. Like everything may seem really good, but then when you put it on an STL software, you'll notice that there is some error coming up. So you can use check for bad objects, which kind of points out exactly where there is a surface undulation, where there's a surface violation, or even if there is an overlap in terms of structural error in a geometry, that will also show up. And then you can slowly, kind of patch up your model. And lastly, all I was saying you is like the manufacturing capacity of this particular software is really good. Is the water type models, preparing a water type models. So we do a lot of prototyping solutions as well, and particularly when the model is developed, we get a really I would say a really bad open model. So when that comes in, we particularly use this command to which is show edges, which shows all the naked edges and then allows you to understand how to kind of fix the file, and we close the model to 3D print. Now, for a very successful 3D print, a closed solid model is required before a valid STL file can be generated. So yeah, these are the tips. Definitely, there are 100 more tips that I can kind of tell you while working on. Yeah, but feel free to kind of mail me or ask me for more solutions. So particularly when it comes to design, and optimization. Like let's say you have done few ideas, but then the client wants a much efficient manufacturing process. Like particularly the next few conditions that I'm going to show you are more into whether how much time does it take, and it's more into FDM technology. Because we work with multiple industrial designers who make limited editions and so on. So I'm just going to share a few conditions, a very simple set of conditions to start making you question while you design whether whether this shape will be good or whether that shape will be good. What is the most efficient shapes, right? So today I'll be showing a few conditions called the corner conditions. So we've kind of tested few geometries out. Uh, so let's say that you take a sharp corner, you take a rounded corner, and a chamfer corner. This all the volumes are almost similar. The dimensions are almost similar. What you notice is that for a nozzle or a travel path to take for 3D printing, the print time takes around 1 hour 18 minutes for a sharp corner. You would notice that out of these three, the least that is taken is 1 hour 11 minutes, which is a chamfer corner, but also because you've eaten quite a bit of the corner portions, right? But then let's say that the fillet corner is one of the least compared to the sharp and the chamfer corner. So what I'm trying to say here is, what if you mix and match? Like I've tried to fuse a chamfer corner and a fillet corner to attain a more optimized solution in terms of timing, in terms of the weight, in terms of the material that it has used, and in terms of the product weight as well. So these are small conditions that you can see. This will make a great change in aesthetics as well. And in terms of consumption and optimization. So it will be a win-win situation from looking at a form perspective and looking at a client perspective, and also in terms of user group, because the more smooth it is, the more elegant a product tends to look. So this is one corner condition that I've kind of we work on in most industrial projects as well. And a lot of emotions too gets generated whenever you kind of round an edge. The tension becomes lesser as well. So yeah, definitely I would go for the last one here. So similarly, looking at porosity conditions, I've been working with quite a bit of understanding how do you work with facades, and how do you optimize those solutions for 3D printing as well. So these are few examples. Think of it as a simple window geometry where you're trying to 3D print. One is a general void, but then this is an FDM based experimentation as well. So the first one is an open condition, the second one is an horizontal lower and a vertical lower. Let's say that all three of them needs to kind of printed on a not on the base plate, but on a vertical position. So finding the optimized solution of the form also matters here. So if you look at it again, in the first case the supports get generated, in the second case, since it's horizontal, the supports get generated, which is a lot of added post-production and so on. But in the last case, since I have vertical louvers, it kind of goes and acts, remember itself acts as a support, right? So if you again look at this, you will also notice that definitely the void consumes lesser time because that doesn't have much material information. But if you compare horizontal and the vertical louvers, notice that again the optimization happens more for a vertical louver rather than for an horizontal louver. So all these things, if you kind of connect what I told before in terms of design optimization, particularly when you're in a design ideation phase, how do you incorporate what happens in manufacturing stage? So these two connect quite a bit. And instead of using in a testing and a simulation phase, try and use this process in a much earlier design stage as well. And lastly, just to show a little bit more shape conditions. So this is something that we also do, because when it comes to manufacturing, we will need to find the fastest way to kind of create a geometry. So looking at shape conditions, all these geometries have the same cubic millimeter, but we also tested this whether whether a circle shaped extrusion works faster or a polygon. You would be definitely a star. Any sharp geometry will take a longer time to print because it has a larger circumference. But you'll also notice that among all of this, circle, definitely, we just had a presentation quite some time back that polygons are the best against by Alex. Yeah, true. You will notice that polygon wins here. But very closely with a circle geometry or with an organic shape as well. Again, there is a lot of definition on how do you define an organic shape, what kind of shapes, what kind of direction that goes in, which is the next part of research that I've been working on. Probably I can share those with you guys in the next year. So this is this is with respect to the shape conditions that you can think of on a form level, particularly when you design. And definitely iterations are a very, very important thing. You can test multiple things, and how we also test it is we either use Slicer or we use Grasshopper, which is a coding language that kind of helps us to create multiple iterations for a singular form. This particular one, what I wanted to convey was not just form. I've kind of combined shape, form, and porosity condition into this. And coming to the next part, I think since we don't have much time, I'm not going to get too much into prototyping, but I would love to kind of share one small project of ours, which is what we call as on-demand manufacturing. Like what we do is we've been with all these optimization and different forms. We've been kind of working on what will be the fastest way to kind of generate a 3D print. And these are different shapes that we've been kind of exploring on a planter level of, this is a product that which is called High on Life. So what is the most optimized one? And the best part of this particular project that I would like to point out here is it is for on-demand manufacturing. What I mean by that is when an order is placed, only then a 3D print is actually done, right? So you don't stock up the parts, you just print it and then you kind of do it and send it out. And this is another one. This is customized. Like we have moved from mass production to mass customization. What I want to kind of tell you here is these are not, I mean, particularly when you're doing, casting. This is a project that I did for the medical team where every single, once we have a CT scan, we prepare a coding language where you just insert the CT scan imagery, the 3D, the file, the scan file. It will allow you to generate a coding surface around it and then create a porosity condition on top of it as well. Again, there is a lot of optimization in terms of printing here as well. So, you don't generate, the structure is not very weak or so. So this is another project. So the first one, this is for on-demand manufacturing. And this, I wanted to speak about mass customization, where we use design and scripting for, creating the end product. So yeah, that's quite some things that I wanted to talk to you about. Another small track that I wanted to kind of introduce here to kind of for designers to contemplate is also on-site construction, like how you kind of develop products. What are the different technologies that you'll need to understand? So those are again some things that designers need to kind of think. And definitely, what are the other types of technologies? Like if you're helping a jewelry designer, what is the best technique or the technology that you can go in for? So that is something that is very important to understand for any designer, to get the right technical or the technological background to kind of go ahead in this particular career. And design and 3D model is the path to a good 3D print. And definitely 3D print will revolutionize the way we think, realize, and produce. So all I want to end is to say that, if you're a designer, if you're any other background, always upskill and adapt to change. Thank you.
Thank you so much, Kavitha. That's you ended on a really great piece of advice there. I think upskill and adapt to the change is a fabulous message. And it's clear that through the course of your career, that's what you've been doing, and just continually adding to your skill base, which I have to say is very, very impressive. So, and thank you so much for sharing all of your design knowledge with us. That was so informative. We have a number of questions. I might just ask one which
Okay.
got the most votes, and then we'll head over to our networking session. So what's your favorite software
Sure.
tool for design?
It's obviously Rhino 3D.
Rhino.
Yeah.
Okay. So I'll tell you what we might do now is we'll go over to the networking session. Kavitha, are you hanging around for a little bit of the networking time?
Sure. Yeah, I am.
Yeah, that would be great.